All right, so we got a video here on multiplying polynomials. Now, you may be thinking that we've already done this before, and we have. We've multiplied monomials times binomials and trinomials, and multiplied two binomials together. But as you can see here, this is just a little bit more advanced now, which just makes it to be a longer problem. We have here is we're going to be multiplying a binomial times a trinomial. Okay, so when we multiply two binomials together, we've used the FOIL process or the box method, and we can use those same methods for a question like this. It's just going to take, like I said, a little bit longer. So why don't we go ahead and go do that? And again, you can do something called the box method. I think we're going to stick with the distributive property, or it's kind of like FOIL for this, but just know that you can go with a box if you prefer. So the distributive property is essentially saying, okay, we want to multiply both this 2x times everything over here in this trinomial, as well as the 5 times everything in this trinomial. Okay, so let's start off with this 2x. So we'll multiply the 2x times the x squared, and that's going to give us 2x to the third power. Okay, then we'll take the 2x, multiply it by negative 3x. That will be negative 6x to the second power. Then we'll take the 2x times the 10, and that will give us 20x. Okay, so we'll now do the same thing with the 5. And we're going to take the 5, multiply it through the trinomial. So 5 times the x squared, that is 5x squared. Then 5 times the negative 3x, that's going to be negative 15x. And then the 5 times the 10, that's going to be a positive 50. Okay, so at this point now we've multiplied everything we need to together. So the last step is just going to be if we can simplify this at all. So we're going to look for common like terms that we can put together to make this a little bit smaller and simpler. Okay, so first of all, we want to go in standard form, which means the highest exponent first. So we see the 2x cubed here. We look around for any other x cubes. We don't see any, so we'll leave that first. That's going to be 2x to the third power. Then we'll look for x squareds. So we do have a negative 6x squared here, a positive 5x squared here. We combine those, that's going to now be negative 1 or negative just x squared, like that. Okay, we'll look for any x's to the first power. There's a 20x to the first power, a negative 15x to the first power. We can combine those to give us a positive 5x. And then finally, we look for any constants. We see this 50 here, and we do not see anything else, so we'll just put that in at the end. All right, so our final answer here is 2x cubed minus x squared plus 5x plus 50, and there's nothing else we can do with that. Okay, so that's how we multiply a binomial and a trinomial. And now let's take a look at another example here. We actually have here our 3 polynomials. We have 3 binomials. And so what we're going to have to do is multiply this binomial times this binomial times this binomial. Now, rather than taking it all at once, what we'll do is we can take any 2 of them that we want to multiply together first, and then multiply the result of that times the third. Now, it does look like right here it's easiest to deal with these 2. And then we'll take the result of that and multiply by the 3x minus 7. Okay, but the order does not actually have to be the case. If you just said, you know what, I want to do this x minus 8 times the 3x minus 7 first, you could do that. That'd be fine. But we'll just go in order here. Okay, and we're going to take this x minus 8 times the x plus 2. And this is kind of basically a FOIL thing going on here. We'll take the x times the x is x squared. Then the x times the 2 is 2x. Then we'll go down here to the negative 8. Negative 8 times x is negative 8x. And then negative 8 times 2 is negative 16. Okay. We can check to see if there's anything we could put together, and we can put together those x's. So the 2x and the negative 8x. So this will now simplify to x squared minus 6x minus 16. All right. So this x squared minus 6x minus 16 is the result of multiplying these 2 together. So now we have to multiply the result of that to the 3x minus 7. So we'll go ahead and do that. Just change this up to green. And I'm going to rearrange it just to put the binomial first. So I'm going to take this 3x minus 7 first, then times the x squared minus 6x minus 16. And then we'll start multiplying. Okay, so just like before, I'm going to take this 3x and multiply it all the way through. So 3x times x squared, that's going to give me 3x to the third power. Then I'm going to take my 3x times negative 6x, and that's going to be negative 18x to the second power. Finally, I'll take my 3x times negative 16. That'll be negative 48, and there will be an x there. Okay, now I'll go down below to this negative 7 and do the same thing. So negative 7 times the x squared is negative 7x squared. Negative 7 times negative 6x is positive 42x. And then finally, negative 7 times negative 16, that's going to be a positive, and then we multiply 7 times 16 together, we get 112. Okay, almost done now. We just need to add up any like terms. I start off here with my 3x cubed, and there's nothing we can do with that, so nothing to combine it with, so we'll keep it as 3x cubed. Then we'll look at the x squareds. I do have a negative 18x squared and a negative 7x squared. If I put those two together, that is negative 25x squared. Okay, looking now for x's, we have a negative 48x and a positive 42x. That is going to be a negative 6x. And then finally, I look for constants. I see that positive 112 there. I do not see any other constants, so I will add that on the end. All right. Let's see if there's anything else you can combine, but there is not. So that is our final answer there. So that's how we multiply polynomials that are a little bit more complex and sophisticated. Hopefully that made sense and that helped. We will do more of these in class, and if you have any questions at that time, you can let me know. All right, thanks.